In section 2.4, we're going to use a lot of the stuff we've already covered and bring it all together to solve these problems. The first definition says to solve a triangle means to find all angles and side measures. So be careful. If an instruction says, here's a triangle, solve the triangle, find all three sides and all three angles. That's what the problem is asking you to do. Okay, so, I say no, don't worry about significant digits. I think I've mentioned that before. Okay, so the first example, this is number 16. So this figure's in the book. So I didn't just make this up. I copied this out of the book. So we have a right triangle, right angle at C. The hypotenuse is little c, it's opposite capital C. Angle A is 31 degrees 40 minutes. Little a is 35.9 kilometers. Angle B we don't know, and the side opposite little b we don't know. Okay, so it says solve the triangle. So it means finds all three sides and all three angles. Okay. Now, obviously they have to give us some information. So when it says solve, when you're doing it, you're working, you give the final answer, you don't have to write down the information that was given. You don't have to tell me C is 90 degrees and little a is 35.9, that's already given. So basically what do we have to find? Little b, little c, and angle B. That's what we have to find. Okay, well usually I approach these problems by finding something that's just easy to find. Well, what's something we can find here without too many problems? Well, angle B, right? We could have done this, several sections ago. Okay, what do we know about angle B? You could use the fact that all three angles add up to 180 degrees, or you can use the fact that the two acute angles in a right triangle add up to 90 degrees, right? So how do we find angle B? B is going to be 90 degrees minus 31 degrees 40 minutes. Right? Notice I'm labeling my work and I'm showing my steps. Right? If you just say B equals and give me an answer that's wrong, I have no idea where you got it from. I can't give you credit. So you need to explain your work. Okay, so again, we've done these before. However you want to do it is fine. You can use the calculator for those of you that have those capabilities. You can do the subtraction and borrowing if you need to, but what does this turn out to be? It's turned out to be, 58 degrees, 20 minutes? That's 89.90, yeah. Okay, so fine. If you want to put that in the picture to help you, that's fine, but please don't just put answers in the picture because I don't always look at the pictures for your answers. I expect to see the work out here and label. Again, if you want to write it in there to use it to help you find other things, that's fine. Oh, also, since this angle was given in degrees and minutes, this should have been given in degrees and minutes as well. Okay, I mentioned that in a previous lecture. If this had been in decimal degrees, angle A, then I would expect B to be in decimal degrees. Okay, so that's the easy thing. So notice we have all three angles now, so we're good. Now we need to focus on the sides. Okay, so we have little a is 35.9 kilometers. Could you use Pythagorean theorem to find one of the other sides? Well, Pythagorean theorem has three variables in it, a squared, little a, little b, little c, a squared plus b squared, c squared. When you have an equation with three variables, if you want to find one of them, you have to know the other two. We only know one side. Pythagorean theorem at this point does not help you. So this is the new thing, okay? When you're solving right triangles, right, that's the name of the section, right? Solutions and applications of right triangles. The procedure is choose one of the acute angles and two of the sides. So notice that's three variables. So of those three variables, you need to know two of them to find the third. So don't choose 90 degrees, choose one of the acute angles and two of the sides. Do that first. I like to choose what was given. So here, I'm going to choose angle A, I'm going to choose side A, and now I need another side. Well, I'll just pick one, C. Okay, so do that first. Choose one of the acute angles and two of the sides. Of those three things, you need to know two of them, so I'm good. Okay, so you do that first. Then ask yourself, from the things I've chosen, what trig function relates these three values? Here's my angle. I have the side opposite, and I have the hypotenuse. What trig function involves opposite and hypotenuse? Well, sine or cosecant. But I'm going to use the calculator eventually, so I might as well just use sine, because if I use cosecant, I'll have to take the reciprocal to use the calculator anyway. So let me say the procedure again. When you're trying to find things, B, we didn't need to use this procedure. We just subtracted from 90 degrees, right? But to find things in right triangles, what do? Choose one of the acute angles and two of the sides. From those three things, make sure you know two of them. Then you ask yourself what trig function relates those three things. So sine is opposite over hypotenuse. So sine of 31 degrees 40 minutes is the opposite 35.9 over the hypotenuse, we'll see. Okay? So don't pick the trig function first, because you may not have the right information. Pick your information first, then pick the trig function, then set up the relationship. Sine of this angle is opposite over hypotenuse. Well, now it's an algebra problem. I'm trying to solve for c. Notice c is in the denominator. We've got to get that variable out of the denominator. So I'm going to multiply both sides by c. Multiply both sides by c. So the c cancels over here. And then divide both sides by sine of 31 degrees 40 minutes. Okay, so I multiply both sides by c to get the c out of the denominator. Then I need c by itself, so I'm dividing both sides by sine of 31 degrees 40 minutes. Notice how my work is very organized and easy to follow. And now we just have to punch that in. So now you see why we did the last section, because we have to know how to compute sine of 31 degrees 40 minutes. That's why we did the last section. So 35.9 divided by sine of, I'm going to use my dividing by 60 stuff, 31 plus 40 over 60. And I got 68.38 kilometers. So there's side C. So what's the only thing left to find? I still need little b. I still need little b. Okay, and I kind of ran out of room. Okay, now, if we wanted to use Pythagorean theorem now to find little b, could we? Sure, because I have side A, I have side C. You could use Pythagorean theorem to find b. Okay? Without doing the work, could you tell me, how does side B compare to side A and side C? You know B has to be less than C because B is a leg and C is a hypotenuse. How does B compare to little a? Is B going to be bigger than side A or smaller than side A? Well, angle B was about 58 degrees, which is more than angle A. So side B is going to be bigger than side A. So it's going to be between 35.9 and 68.38. So that would give me an idea if my answer makes sense. Now, I could use Pythagorean theorem to find B, and it's fine if you do, but just to practice this new procedure, let me just do it that way. Okay. See. Now, if you want to use side C to help you find side B with the procedure, that's fine, right? I like to choose what was given because that answer is rounded. I don't want to round on the rounding. Sometimes you have to, though. So I'm going to pick the angle that was given, the side that was given, and side B, which I don't know. Okay, so pick one of the acute angles and two of the sides. I know two of the three things. Then you ask yourself, what trig function relates this angle to these two sides? So I have opposite and adjacent, so that involves tangent. So tangent of 31 degrees 40 minutes is the opposite 35.9 over B. Okay, so tangent is opposite over adjacent. And now we have to solve for B. Notice B is in the denominator just like this one was. So I'm going to multiply both sides by B. And I need to get B by itself, so I'm going to divide both sides by that tangent. And so when you type that in, we'll see what we get for B. I hope I wasn't standing in the way and you couldn't see. Maybe. I got 58.20 if you go to two places. Okay? So there's just one little new procedure here. When you're solving right triangles, if I had known A and B, I could use Pythagorean theorem to find C. That's fine. But like here, Pythagorean theorem, when we started, we didn't know two of the sides, we couldn't use it. Choose an acute angle and two of the sides of those three things. Make sure you know two of them, right? So choose those. Then ask yourself what trig function relates them. Set up the trig function, procedure. Tan of an angle is opposite over adjacent. Sine of an angle is opposite over hypotenuse, right? And then you do some algebra. Now, something I didn't use Pythagorean theorem to find my answers. What I could do to check, it's always nice to check a completely different way, is 35.9 squared plus my b squared equal to my c squared. 35.9 squared plus 58.2 squared is 4676.05. 68.38 squared is 4675.8. I'm off by, 0.23-ish. So because of the rounding, I'm off a little bit. So I think I'm good. So it's nice to do it this way, and then I can check my answer with Pythagorean theorem. Okay, so that's a problem. So you don't have to put, boxes around the answers or anything. If you are organized, granted I ran out of room, but it's clear I'm finding side C here. And notice I've labeled C equals. It's clear I'm finding side B because there's my variable B, right? And I've labeled, and my answer's at the end, right? Same thing for B. Okay, so that's that problem. So the next one, this is number 35. Now there's no picture on this one, that you don't need a picture because of the way they've labeled the information in the problem. So number 35 says, solve the triangle where little a is 18.9 centimeters, little c is 46.3 centimeters, and capital C is 90 degrees. A is 18.9, C is 46.3. So give angles in degrees a minute. So I have to remember angles are in degrees a minute, okay? And the third side measure, so the other side is to 2 decimal places. Okay, that's just to help me remember. So solve the triangle means find all 3 sides and all 3 angles. Okay, I think I'm going to draw a picture just to help me visualize. So it's a right triangle because C is 90 degrees. I'm not necessarily trying to draw a scale here. There's C. Little c is 46.3. That's on the hypotenuse because little c is opposite big C. It doesn't matter which one you call A or B. I'll call that A and that B, which means little a is down here, 18.9. If you called that capital A, little a would have been over here. Doesn't matter. Notice in this problem, we're given different information than the last one. In the last one, we had an angle and we had one angle and, besides C. We had one of the acute angles and one of the sides. Here we have 2 of the sides and no acute angle, so it's a little bit different. Well, what's something easy we could find right away? We could find little b, can't we, with Pythagorean theorem? So why don't we just go ahead and do that? So b squared plus 18.9 squared is 46.3 squared. Right. The length of the leg squared plus length of the leg squared is length of the hypotenuse squared. So if I subtract the 18.9 from the square from both sides, I get 46.3 squared minus 18.9 squared. I'm just doing it this way instead of typing the whole thing. Okay, now I think I'll type that in. 46.3 squared minus 18.9 squared is 1786.48. And now to solve for b, I need the square root. Positive square root is, it is said to do 2 decimal places, so 42.27 if I go to 2 places. 42.27. Okay? Okay, so I did that. Okay. And notice the answer makes sense so far because b has to be less than the hypotenuse, which it is. Right? Which angle is going to be larger, A or B? Right? Notice little b is bigger than little a, so angle B is going to be bigger than angle A. Again, I'm not trying to draw this to scale. Look, my 18.9 is almost as big as my 46. But okay? Okay, so that's a part we could just do easily from stuff we've done before. So if you want, again, if you want, you can put that in the picture, 42.27 if you want. If you want to use it, you can, but realize you're rounding on the rounding. Okay, now we need to find either angle A or angle B. Once you have angle A, getting B is easy or vice versa. Okay, so let's try to find angle A. What's the procedure? Choose one of the acute angles and 2 of the sides. I'm going to choose the 2 that were given because I haven't rounded. If you want to use B, that's fine, but again, when you show your work, I will know you're using B. So when you round on the rounding, that may be, if your answer is a little bit off from mine, I'll know why. You have to show your work. Okay, so I chose an acute angle and 2 sides. Then you ask yourself, what trig function relates that angle to those two sides? Well, that's the side opposite A and the hypotenuse. And what's involves opposite and hypotenuse? That's sine. So sine of A is opposite 18.9 over hypotenuse 46.3. Sine of A is opposite over hypotenuse. Right? And notice, of the three things, I know two of them, so we ought to be able to find the third. Now, I cannot tell you how many times I've had students get to this point on an exam and then not know what to do. Okay. Notice, whether you're trying to find an angle or a side, unless it's Pythagorean theorem or subtracting, one of the angles from 90 to get the other, one of the acute angles from 90 to get the other, it says choose an angle, an acute angle, and two sides. Students will do that, and then they don't know what to do. Remember, this is from the last section, okay? Sine of an angle is a number, so the angle is sine inverse of the number, okay? You have to remember stuff from previous sections. You can't just purge once we're done with the section and we move on. Sine of an angle is a number, sine inverse of the number is the angle. Okay, so that's what we need to type in. Sine inverse 18.9 over 46.3. Now, I wrote a whole bunch of decimals on purpose. 7 and then 256. Is that the answer they want here? And that's what I got. I rounded to 5 places. Okay, don't forget. The instruction said, give the angles in degrees and minutes. So they want us to round to the nearest minute. This is not the answer they want. Okay, you have to follow the instructions. So we need to convert this to degrees, minutes, and seconds. Sorry, degrees and minutes, not seconds. All right, so again, those that have a TI-84, remember, this is easy. You go to the angle menu number 4. I'll just go ahead and do that. Angle menu number 4. And it tells me it's 24 degrees, 5 minutes, and 32 point something seconds. Okay, so it's 5 minutes and 32.181 seconds. So I didn't type that, I used the whole thing, more decimals even, right? 32 seconds is more than 30 seconds, which is halfway, right? 30 seconds is half of a minute, so I'm more than that, so I have to round up to 6 minutes. Okay, remember, 32 seconds is more than half a minute, so I have to round it to the next minute. Okay, so that's the answer they want there. So you don't even need to write this step. I was just saying if you realize we needed to go to degrees and minutes. Again, if you don't have the calculator that can do that, remember what you do, you take the decimal part off of the answer I had, multiply by 60, and that'll give you your minutes. So if I did 0.09227.256 times 60, I get 5.5 minutes. So that's more than half. So I round up to 6, so that's fine too. Okay. Now if you want to, how do we get angle B? Subtract that from 90. And that's perfectly fine, you can do that. But just because we're in this section, I want to practice our method here. So let's pretend we hadn't done that at all. And I was looking for angle B. Okay, so again, if you want to subtract this from 90 to get angle B, that's what you should do. Okay, but just to practice our new method here, what am I going to do? I'm going to choose angle B, the acute angle B, and choose the two sides that we're given. Now, what trig function relates angle B to these two? Notice this is the adjacent, the hypotenuse compared to B, so that's cosine. So cosine of B is 18.9 over 46.3. Cosine's adjacent over hypotenuse. Cosine of an angle is a number, so B is cosine inverse of the number. Okay, so when I take cosine inverse of that, 18.9 over 46.3, I get 65.9, but they want degrees and minutes, so let's go ahead and change that. Again, however you know how to do that is you do. So I got 65 degrees, 54 minutes and almost 28 seconds. That's not half, so I leave it as 54. Okay, so what are the three things that were missing? Little b I found, and both angles I found. Now, a good reason to do it the way I did is, even though it takes a little bit longer, is A and B are complementary angles, right? They have to sum to 90. That's 89, and one more degree, that's 90. So that's a good way to check my work. If I had subtracted this from 90 and made a mistake, I'd never catch my mistake. Okay, so that's that one. Okay, so two more. Luckily, the next two, they don't have us find everything. So they won't be as long as these two problems. It doesn't say solve the triangle. All right, so number 46, there's a diagram in the book. So let me draw. So they have this triangle. That here's R, and here's T, and here's S. And it's this line segment RS is spanning a lake. There's a lake like this. Okay, so that's the picture in the book. It says to find the distance RS, so to find this distance RS across the lake, a surveyor lays off length RT, which turns out to be 53.1. So let me add that to the figure. So RT is 53.1 meters. So that angle T is 32 degrees 10 minutes. So T is 32 degrees 10 minutes. Okay, fine. And angle S, well, they're being very generous here. I didn't leave a lot of room here. S is 57 degrees 50 minutes. Do they really need you to tell you S? They're being generous. They told you T, that you know there's a right triangle. That's part of the picture. You could have figured out S. So they were generous. They didn't need to give you that. It says find the length RS. So this distance. I don't know why they're using RT and ST and RS. I mean, what's the common way to call that distance there? It's opposite angle T. It would make sense to call that little t and to call this little s, right? So I don't know why they did that here. Okay, so I like this problem because it's sort of a real life application, right? You've seen surveyors out there, you know, doing road construction. They have their tripod and they have a little, you know, mechanism on top, and you see the person looking through it, and there's somebody standing down the road holding some sort of flag or something, and it records distances and you can do angles. So the idea here is they want to know the length of the lake. Well, you can't just walk across the lake, right? Or a problem with an obstruction, like suppose there's a big tree right in the middle of this, and so the surveying equipment can't see through it. So what do? Well, they measure this way, right? There's no obstruction, no lake, and then they measure this way. You know, suppose there's no obstruction there. I kind of drew it like there is, right? So what do? So then you make a triangle out of it and use trigonometry to figure out the distance you couldn't do with your equipment. So I like this example because it's the sort of thing that you would have to do if you were working in construction or surveying. Okay, so we're looking for this distance right here. Right? So notice if they hadn't given us S, we wouldn't need S. It didn't say solve the triangle, right? It just said find this distance little t. Well, what's the procedure? Choose one of the acute angles and two of the sides. Make sure you know two of the three things. We do. So I don't even need this up here. I don't even need S. I don't know why they gave it. I could have used S if I wanted to in solving the problem, but I just picked T because it was right there. Right, so I chose one of the acute angles and two of the sides. I know two of the three things. Do not choose the right angle when you do these problems. Now, what trig function relates this angle to these two sides? It's opposite and adjacent, so that's tangent. So tangent of 32 degrees, 10 minutes is the opposite side, T, over the adjacent side, 53.1. Right, so tangent's opposite over adjacent. Notice if I had used angle S, it still would have been tangent, wouldn't it? Because it would have been opposite and adjacent. I still would have used tan. Okay, now I'm trying to solve for T. Now this is a little bit easier than ones we did a while ago because the variable's in the numerator. How do you get T by itself? We just need to get rid of the 53.1. Multiply both sides by 53.1, and you've got T, right? Multiply by 53.1, you get that. Multiply by 53.1, the 53.1's cancel, you're left with T. So the algebra here is easy. So T here, if we punch that in, is T going to be bigger than or less than 53? Right? This angle was bigger than the 32, so this side is going to be bigger than T. So T should be less than that. So 53.1 tangent of 32 plus 10 over 60. I got 33 point, well, did it say what to do? No, I'll just round it to a couple places. If you round to 3 places, it's 396. Now, there's no good way to check except for checking my own work because I didn't find anything else. But notice the answer is less than this side, which I knew it would be. So that's something. Okay. Now to do the last problem, we have to have some definitions. Notice on this problem, I did not find everything because it didn't say solve the triangle. Don't do extra work if it's not asked for. Okay, so we need to talk about angles of depression and angles of elevation. Okay, so I get to use my my excellent art skills again. So suppose you have a guy here, and you have the sun here, right? And they ask for the sun's angle of elevation for the guy. So the guy's angle of elevation to the sun. Let me draw a triangle here. I'm gonna draw a right triangle here. Okay. Now angles of elevation and depression, which we'll do in a minute, are measured from the horizontal. So you ask yourself, if this guy were looking straight on, through what angle does he have to raise his head to see the sun? So you measure from the angles of elevation are measured from the horizontal up. So where's his angle of elevation in this picture? It's here. So this is the angle of elevation to the sun. So his angle of elevation to the sun, measured from the horizontal up. Okay, so there's his angle of elevation. Now, on the other hand, suppose I have a guy on a cliff, and his friend is down here, and we ask, what is the angle of depression, okay? So let me just draw a triangle. So I'm saying he's right here, his eyes are here, that's fine. This isn't super precise, but, so there's my triangle picture. Now, where is that guy's angle of depression to see this guy? Now, be careful, your eyes might just say, oh, well that, because it's, you know, it's the down angle, but be careful. That's why you have to, don't let diagrams force you into a situation that's not right, okay? Remember, I said angles of elevation and depression are measured from the horizontal. So his angle of depression is from the horizontal down, okay? This is from a vertical over, right? That's not the same thing. Angles of elevation and depression are measured from the horizontal. So I'm the guy on the cliff, my angle of depression is from here down. Notice that is not here, right here. So if you really want to put it in, you have to add this horizontal in. There's his angle of depression. Okay, so be careful. Don't let the picture mislead you into putting the angle in the wrong place. Right. Now, where is this guy's angle of elevation to his friend? Right, so for him, it's from the horizontal up. His angle of elevation is here. Right, that's his angle of elevation, isn't it? Now, how does his angle of depression compare to his angle of elevation? Notice you have two parallel lines that are horizontal, cut by a transversal. These are alternate interior angles, so they're equal. So if you have a picture and you're asking his angle of depression and you don't want to add to the picture, realize it's this guy's angle of elevation, which you could have put here. So you could add to the picture and put it here, or you could just put the angle of depression as his angle of elevation because they're the same. Okay, so again, be careful. Don't let the picture mislead you into just putting it inside the triangle. Okay, with those definitions, we can do this number 54. An airplane is flying 10,500 feet above the level ground. Okay, so we have level ground. Okay, this is going to be embarrassing. Here's my I don't know how to draw an airplane. So there's a pilot up here, and there's a wing, and there's something back here. I don't know. Oh, that's embarrassing. Okay, well, and lots of windows. Well, there's nobody on the plane right now because everybody has the coronavirus. Okay, so it's flying 10,500 feet above the level. They told you level, so you know this is a right angle. So 10,500 feet above the level ground. Okay. The angle of depression from the plane to the base of a tree. So there's some tree down here. Okay, so there's some tree down here. I'm just going to make a triangle out of this. I guess really this should be at the front of the plane. That's fine. Okay. the angle of depression from the plane to the base of the tree is 13 degrees 50 minutes. Now the angle of depression is here, which is the tree's angle of elevation, so I'll just put that down here like we just discussed. That's 13 degrees 50 minutes. If I had drawn the triangle this way, right, I could have put the 1350 in there. How far horizontally must the plane fly to be directly over the tree? Now be careful. This is not the distance they're looking for. It doesn't say how far does it take for the plane to crash into the tree. That's not what it asks. It's asking how far horizontally does a plane fly to be directly above the tree? Well, that would be this distance down here. I'll just call it X, right? The distance it would have to fly to be over the tree is the same as the distance down here. So the hard part here is just drawing the picture. Once you have the picture, it's not a hard problem, right? They didn't ask for everything. All they wanted was this distance right here. Right? So if you had drawn it this way, I would have the 13 degrees 50 minutes here. I would have the 10,500 here, and that would have been my X. But these are congruent triangles, so it doesn't matter. Okay, so what's the procedure? Choose one of the acute angles and two of the sides. Make sure you know two of the three things, which I do. Then you ask yourself what trig function relates this angle to these two sides. This is opposite and adjacent to 13 degrees 50 minutes, so that's tangent. So tangent of 13 degrees 50 minutes is the opposite side, 10,500, over the adjacent side X. Okay, so I'm following the same procedure we did before. All the work here is just setting up the picture. Okay, now I want to solve for X. X is in the denominator, so let me get it out of the denominator. Let me multiply both sides by X. Alright, multiply both sides by X, that's the resulting equation you get. And then I need X by itself, so I'm going to divide both sides by that tangent. So we know how to type this in. So 10,500 divided by tangent of 13 plus 50 over 60. And I'm getting 42,641 point, I'll write them all, 2351 feet. This distance was given in feet, so this distance is given in feet. 42,641.2351. How far is that? Is the plane getting close to the tree? Is it far from the tree? Well, remember, a mile is 5,280 feet. So just out of curiosity, if I divide that by 5,280, it's 8.08 miles. So it's a little over 8 miles, just to get a good feeling for it. This goes back to the conversation I had before when we were doing degrees, minutes, and seconds. You may not have a good feeling for 42,641 feet, but 8.08 miles, oh, okay, you have a good feeling for how far that is. So that's why it's nice to have different units of measure for the same, for length, say. Okay, so that's the last example here.